Good afternoon, students. Today, I am going to start with the subject wireless communication system. And you also should came to know that the subject code for that is here ACEC 16601. And I am your professor in the Department of Electronics and Communication Engineering. And I welcome to all in the sixth semester. Okay. Now we are going to discuss in this semester wireless communication system. As you know that we all are using the mobile, okay, and the mobile communication is actually wireless communication. So this subject is very interesting because we are using these wireless communication in our daily life. Firstly, before going to the course curriculum, before going to start the course curriculum, actually I want to discuss the importance of this subject. Okay, so in the form of your program outcomes and your course outcomes, then I will discuss with you your course curriculum or the syllabi of this subject. Okay, now I am going to start with the program outcomes. Now what is program outcomes? I am going to the next slide. Yes, program outcomes. Actually, program outcomes means after learning this subject means what is the motive behind this subject to teach the students why they need this subject in their course curriculum. Okay, so I will discuss these PO one by one. After this course curriculum, course outcome will be discussed. Firstly, first program outcome is that for this subject is apply the knowledge of mathematics. Actually, you can also have the knowledge of mathematics, science, engineering fundamentals, and an engineering specialization to the solution of complex engineering problem. Second program outcome for this subject is you have to identify, formulate, and analyze the complex engineering problem in your field of your ECE, that is electronics and communication engineering. Third program outcome is design solution. We have to design the solutions for the complex engineering problems and design system components or processes that meet the specified needs with appropriate consideration for the cultural, societal, and the environmental considerations. Next is your program outcome 4 is use research based, actually use research based knowledge and research methods, including design of your experiments, analysis and interpretation of data, and the synthesis of information to provide valid conclusions in the field of your electronics and communication engineering. Next is your PO5. PO5 is program outcome 5 is to create, select, and apply actually, and your apply your appropriate techniques and resources, actually resources and modern engineering for modeling of complex engineering activities in the field of communication networks. Program outcome sixth is apply reasoning by the contextual knowledge to assess societal, health, safety, legal, and cultural issues, and the consequent responsibilities relevant to the professional engineering practice. Program outcome 7. Understanding the impact of professional engineering solutions in the societal, environmental context and demonstrate the knowledge and need for them. Next is program outcome 8. Apply the ethical principles and commit to professional ethics and responsibilities and norms of the engineering practice. Next is your program outcome 9. Program outcome 9 is function effectively as an individual and in a teamwork for a multidisciplinary settings. Program outcome number 10 is communicate effectively on complex engineering activities with engineering community and with society at large, such as being able to comprehend and write effective reports and design documentation, make effective presentations. Now the program outcome 11. Demonstration of the knowledge demonstrates the knowledge and the understanding of your engineering and management principles and apply these to one's own work as a member and as a leader. Program outcome 12. Recognize the need for and have the preparation and ability to engage in independent and lifelong learning in the broadest context of technological change. So these were the some of the program outcomes for this subject. So now I can summarize the program outcome for this subject is actually, firstly, we should have the knowledge of mathematics, then we should identify or analyze our problems, then we have to design solutions for them, and we have to also we have to use the research based knowledge also for that applications. Okay, so and next compiling up again your program outcome, creating and selecting actually appropriate techniques for that design. Then we have to responsible for the our contextual knowledge to assess the your health, safety, legal, culture, societal issues. Then understanding the professional engineering solutions also, and ethical principle also apply the ethical principles, and we should have to perform our function in the teamwork and communicate effectively on the complex engineering activities, and the knowledge we should have the knowledge and understanding of your engineering and management principles. And last program outcome is you we should have the preparation and ability to engage in independent and lifelong learning in the broadest context of your technological change. So these were the some of the program outcomes for your wireless communication system subject. Now come on to the next is your course outcome. Okay, so next is your course outcome means after learning this subject, what the concepts you will learn, okay, at the end of this course. Okay, first is here you will have the knowledge of your basics of your wireless communication techniques. Next is understanding the actually elements, what are the various elements of the cellular radio system. Then what are the issues related to the digital communication through your fadings and your diversity techniques and in your wireless communication. Then the course outcome fourth is introduction to various multiple access techniques like TDMA, FDMA, SDMA. Okay. Next is your next course outcome is your knowledge of wireless systems and standards. And next last course outcome is your familiarization with different generations of cellular system network and its architectures. Means 4G, you will learn about the 2G, 3G, 4G, 5G, all architectures will be discussed in this course outcomes. And you know that 4G we are using in our mobiles, 4G, fourth generation actually, and we will learn the architecture in this subject also. Okay, so these were the some of the course outcomes of your subject, wireless communication system. Now I'm Now, further, I will discuss with you the syllabus or the course curriculum of this subject. Okay. Next is your syllabus. Okay. In this syllabus, in your course curriculum, your whole syllabus is divided into 4 parts. Okay. In the part number 1, we have the introduction and elements of cellular radio systems design, in which we will do the basics of your cellular systems, cellular radio systems, and wireless. Like I will teach you what is basic cellular system, what are the limitations of that, then what are the various performance criteria, how a cellular system is operated, planning of a you're planning a cellular system, what are the analog and digital cellular system, then what is the general description of the problem, concept of your frequency reuse channels, four channel interference reduction factor, desired C by I, actually C by I matlab carrier to interference ratio, what is the effect of that, then how cells are separated, and components of cellular systems, that will be included in your part number 1. Now, in your part number 2, we will learn about the what is fading. Actually, fading is the weakening of weakening these signal strength, that is known as your fading. Various type of fadings. Then what is the concept of diversity? Diversity is used to combat the effect of your fading. So what are the various diversity combining techniques? Then what is relay and Gaussian distribution? Then what are the various multiple access techniques like FDMA, TDMA, spread spectrum, SDMA, space division multiple access? All these will be covered in this part number 2. Now come on to the next part, that is your part number 3. Okay, in part number 3, I will teach you the various wireless systems used, like first generation is your AMPS and ETEX, then IS-54, IS-136, then GSM, then GPRS, UMTS, CDMA, then your rate receiver. All these topics will be covered in this chapter. Okay. Next, last part number 4. Part number 4 is your future trends. Means we will learn about the 2G architecture, 3G architecture, 4G architecture, LTE, advanced systems, long term. LTE stands for your long term evolution. Okay. And we are using 4G LTE in our mobiles in daily life. 5G architecture, all the architecture introduction will be learned in this chapter. So this was the your syllabus. Whole syllabus is divided into 4 parts. So in this PPT presentation, we came to know that about the program outcomes, then your course outcomes, and last is your syllabus. How the course curriculum, what the topics will included in that. Okay. Now further, I will start the first chapter, and we will start the first chapter with the first topic, that is basic cellular system. Anji. Now students, I am going to start your first chapter, that is introduction and elements of cellular radio system design. Okay. So in this chapter, now I am going to the next slide. In this chapter, I will teach you the first topic, that is why cellular mobile systems. Why we need cellular mobile systems in our life. Okay. So actually, there are some limitations of your conventional mobile telephone systems, like limited service capability, poor service performance, then inefficient frequency spectrum utilization, These all are the sum of the limitations. That's why we are using the your cellular mobile systems. Okay, now I am going to start this topic in detail. Okay, we know that one of the many reasons for actually developing a cellular mobile telephone system and deploying it in it as in many cities for their operational limitations of conventional mobile telephone system, that is your limited service capability. Second limitation is your poor service performance, and third is your inefficient frequency spectrum utilization. Now I will discuss these these limitations, these three limitations one by one in detail. First is your limited service capability. Okay, in limited service capability, actually a conventional mobile telephone system is usually designed by selecting one or more channels from a specific frequency allocation for use in autonomous actually geographic zones. The communications coverage area of each zone is normally planned to be as large as possible, which means that the transmitted power should be high as the federal specifications allows. Actually, mobile communication, wireless communication, cellular communication, that depends upon a federal specifications. A committee which allows these specifications or bandwidth specification, that is your federal specifications. The user who starts a call in one zone has to reinitiate the call when moving, actually when we are moving into a new zone. Actually you can see I have made a call in this zone, and I am in a car, and I have crossed this area and goes into this area. So we should reinitiate the calls because cell site changes. These two are the different cell sites, F1, F2. Okay. So because the call will be actually dropped, so this is an undesirable radio telephone system. There is no guarantee that a call can be completed without a handoff. Handoff a procedure means when we are going from one zone to the another zone, then your call should not be dropped, and the previous cell site hand should hand it over to the next cell site. So the handoff is the process of automatically changing the frequencies as the mobile unit moves into a different frequency zone. So that our conversation on the mobile is to be continued in a new frequency zone also without redialing the number again. And the second another disadvantage is that of the conventional system is that the number of active users actually are the limited to the number of channels assigned to a particular frequency zone. Means we limit number of active users due to the limited number of channels. But number of channels should be increased to accommodate the more and more active users. This was the first limitation of your conventional mobile system. In conventional mobile system, we use high power, larger cell. Means this is the one cell and having the high power. Okay. Next is here. So this is the disadvantage. I the number of channels. Next is your next limitation is your poor service performance. Actually, in the past, we have a total 33 channels which are allocated our three mobile systems. Actually, we have three mobile systems. First is your MTS, full form that is mobile telephone service, and that works on your 40 megahertz. Next is mobile telephone system is IMTS, and this is improved MTS version. And further, it has next further it is designated as MJ 150 megahertz. Actually, MJ system is operates in the VHF band. VHF means very high frequency band. And both above means MTS and MJ 150 having only the 11 channels. Okay. Now next come to the improved again. Improved MTS, IMTS version is MK. Now this is MK. And the frequency band used is here 450 megahertz, and it provides the 12 channels and working is in the UHF band. UHF band means ultra high frequency band. So if I will total the channels, that is 11 plus 12 is 33 channels. And these 33 channels must cover an area of 50 mil in diameter. Okay. So in 1976, actually, New York City had actually 6 channels. Okay. So, and the MJ, at that time, MJ systems was serving the 320 customers only. And with another 2,400 customers were on the waiting list. And in New York, 6 channels, if you are using the MK system, then 225 customers we can handle, and 1,300 customers was in the waiting list. So 6 channels of MK serving 225 customers with another 1,300 customers on a waiting list. Next is here the larger number of subscribers. If customers, large number of customers created, then your call will be blocked during the busy hours. Although the service performance was undesirable, actually, because the demand is great, because the number of customers are more and more using the mobile. So we need, in that case, we need high capacity system for mobile telephones. That's why we need cellular mobile telephone system as compared to your conventional mobile system. Okay. Next part is your inefficient frequency spectrum utilization. Next is your inefficient frequency spectrum. Third limitation is inefficient frequency spectrum utilization. Actually, in a conventional mobile radio system, telephone system, the frequency utilization measurement actually is MO, is designated by MO, and the defined as the actually maximum number of customers that could be served, that can be served actually, that can be handled by one channel in the during the busy hour. Okay, so MO is the number of customers per channel, means if I have the one channel and one channel, how many customers can be served by one channel? So MO. MO is 53 customers per channel can be handled in the case of your MJ system, and 37 customers can be handled per channel for the MK system. Assume, actually now we are assuming that the average calling time is your 1.76 minute, and we are applying the Erlang B model. Okay, your mobile communication efficiency is given by the formula Erlang B or Erlang C. Efficiency of your mobile is given by the formula Erlang B or Erlang C model. Erlang B model consider the lost call cleared conditions, and Erlang C, whereas Erlang C deals with the blocked calls. So if I will apply the Erlang B model, the offered load will be given by the formula, that is capital A is equal to average calling time, that is your 1.76, into multiply by total customers divided by 60 minutes. Okay, if I will calculate this, then for MJ system and MK system, for two different systems, so A1 sorry A1 is equal to 1.76 into 53 into 6 by 60. So 1.76 into 53 into 6 divided by 60. As I have already told you that 53 customers, in the previous slide I have shown MJ system have the 53 customers and MK have the 37, and we are using the 6 channels at a time. So average calling time is 1.76 into 53, total customer 53 into 6 channels divided by 60 will give you 9.33 Erlangs. Whereas in case of A2, it will gives you 6.51 Erlangs in the case of your MK system. Now what these calculations tells us? If sorry, if the number of channels is 6, so the offered load actually is calculated as A1 is 9.33 and A2 is 6.51. And if I will follow the Erlang B model, so I will show you a table. You can see this is the Erlang B model. For number of channels 6, if I will see that 10.4 is on the 50% blocking. Blocked calls cleared means the number of calls which are blocked are cleared only 50%. Okay, so this is the table from where I got this. B1 is your 50%, whereas B2 is your 30%. B2 is your 30%. As you can see, 9.33 value is approximate in this column, so 50% blocking. And your second one was your 6.51, and if you see 6.51 under your 30%. So B2 is 30%. It means that half the initiating calls will be blocked. Actually, if you are initiating the 100 calls in your MJ system, 50 calls will be blocked. So it means very high blocking probability in case of your MJ system. Whereas in case of MK, only 30 calls will be blocked. Okay. So next is your actually the average calling time. If I will take the average calling time that is greater than 1.76, then of our overall blocking probability also will be high. So if I want to reduce the blocking probability, I should decrease the MO. And as far as we consider the frequency spectrum utilization, so whole spectrum is not utilized properly. Means each channel can only serve one customer at a time in a whole area. So a new cellular system we have to design so that frequency spectrum utilization is maximum and it should be efficient, and this will be overcome by the new cellular system. So this was the basic behind that why we need our cellular system in comparison to the conventional mobile system. Next is your next under consideration is your spectrum efficiency consideration. Actually, a major problem facing the radio communication industry is the limitation of the available radio frequency spectrum. So, FCC, that is Federal Communication Commission, seeks the system which need minimal bandwidth but provide the high usage and the customer satisfaction. So, the ideal mobile telephone system should operate within a limited assigned frequency band and serve unlimited number of users in the unlimited areas. There are actually three major approaches to achieve the ideal conditions. First is use single sideband. Actually, it divides the allocated frequency band into maximum number of channels. Second is we should use the cellular, which reuses the allocated frequency band in different geographic locations. Means we can reuse the frequency band. Same frequency should be used in two different areas. Next is your spread spectrum or frequency hop you should use, which generates many codes over a wide frequency band so that we can accommodate more number of customers. So with these techniques, we can use the spectrum efficiently. Now, next is your technology, feasibility, and service affordability. Actually, we know that in the era of computer industry, microprocessor and mini computers actually are now used for controlling many complicated features. So these achievements were actually a few of the requirements for developing advanced mobile phone systems, and encouraging engineers to pursue this direction because the technology was advanced. And the another factor is was price reduction of the mobile telephone unit used with the use of LSI technology. LSI stands for large scale integration, and mass production contribute to the reduced cost. So next is here also we have a multiple access techniques like spectrum. We have technology, advancement technology in that. So these were the some of the issues why we need, why we should go into the direction of your cellular mobile phone system. Next topic is your why 800 megahertz band is used for the communication. There are so many points. If we are using the low frequency band, actually we have to deal with the spectrum limitation. And if we are going for the higher frequency bands above 800 megahertz, then we have to deal with the severe problems due to your propagation path loss, multipath fading. So, as we know that because of severe spectrum limitations at lower frequency bands, FM broadcasting services operate at the 100 megahertz. Television is operate at the 41 megahertz, and it can be extended up to your 960 megahertz. So fixed station services also allocated portions 30 to actually 100 megahertz they are using. So lower portion is used by your air to ground systems also, maritime systems also, military aircraft systems also. So it is already so much crowded. That's why we are using the 800 megahertz. Now the second reason I have already discussed, that propagation path loss due to your high, band. On the other hand, actually mobile radio actually transmission can't be applied at 10 gigahertz or above due to the some problem like propagation path loss, multipath fading. So actually 800 megahertz actually originally assigned to actually an educational channel, educational TV channel. That's why we are using the 800 megahertz, even though it is not ideal transmission medium for mobile radio, but effect of your spectrum limitation, propagation path loss, multipath fading, these are less affected in this band. That's why we are using the 800 megahertz band. So communication is mostly done in your 800 megahertz band. Okay, students, now we will do the next concept, that is a basic cellular system. Actually, a basic cellular system, this is the diagram for the basic cellular system. A basic cellular system actually consists of three parts. One is your MTSO. Here it is written MTSO, that is mobile telephone switching office. Second is your cell site, and third is your mobile unit. So this is the cell site, okay, and this is the mobile unit. So mobile unit, cell site, and MTSO, three basic your parts of your basic cellular systems. And this diagram actually shows the connections to the link the three subsystems, how these three subsystems are linked. For now, I will explain you part by part what is the function of your mobile unit, cell site, MTSO, these all. So first is your mobile unit. Actually, a mobile telephone unit contains a control unit, a transceiver, and an antenna system. Means your mobile telephone has the control unit, transceiver means you can transmit or receive also, and antenna system. Second is cell site. Cell site actually provides the interface. This is the cell site. It provides the interface between the MTSO, this is MTSO, and the mobile unit, means, and this mobile unit, means link provided by this. Okay. So also it has a control unit, radio cabinets, antenna, power plant, and your data terminals. All these components are included in the cell site. This is your cell site, and this is your cell number 1. This is cell site number 2. Data link means which provides the data, and voice, where you can send your voice data. Landline telephone network can also communicate with the MTSO. Okay. And MTSO includes the switches and various processors. Now MTSO actually, it's the switching office actually, the central coordinating elements for all the cell sites. Means if I want to communicate one cell site with the another cell site, this is responsible for that. It contains actually the cellular processor and cellular switch, and it interfaces with the telephone company zone offices and controls actually call processing and handles the billing activities. All will be done by your MTSO. Last is your connections, the various connections which are linked all the devices, all the components. So connections, actually the radio and high-speed data links, these have written high-speed data links, connect to the 3 subsystems, and each mobile unit can only use one channel at a time for its communication link. But you know that channel is not fixed. So it can be anyone in the entire band by the serving area, with each site having the multi-channel capabilities that can connect simultaneously to the many mobile units. As we came to know that your MTSO actually is the heart of the cellular mobile system. Its processor actually provides the central coordination and cellular administration. So the cellular switch, which can be either analog, the switches which you can see in this diagram can be analog or digital. Switches calls to connect the mobile subscribers to the other mobile subscribers and gives us the nationwide telephone network. It uses the actually voice trunks also. It contains the data links also. Radio link actually carries the voice and signaling between the mobile unit and the cell site, and high-speed data links cannot be transmitted over a standard telephone trunks. So it can use microwave links or the T carriers. Digitally, T carriers, it can handle the both voice and data between the cell site and the MTSO. So this was the explanation of a basic cellular system. With this, I have concluded this lecture. We have covered 2 topics: limitations of conventional mobile system, and second is basic cellular system. In the next lecture, we will do the next topics. Thank you.